Well, what I want to show, this is things go on before you apply any machine learning. There's quite a few machine learners available. I want to focus on genetic programs. They seem to work best for using financial data. At least that's been my experience. So I'll give you a quick intro to genetic program. Let's say we have variables x, y, and z in some result. We're trying to figure out the relationship of the x, y, and z with the result. Well, we randomly create these equations, and just like in genetics, we crossbreed the dominant recessive genes. So the genes in this case are equations. We have some equations that we randomly generate, and then we come up with the fitness value. And you know Charles Darwin's survival of the fitness. So this really, the fitness value in this case, we apply the equation to the population, and then we might have 1 over standard error. The higher the value, the more fit the equation is perceived. Finally, we do some breeding of the equations, and so I chose the first two equations. I color-coded this blue and this one red, and then we swap part of one with the other. We generate brand new equations. And we go through this process. We might go through 50 times, 50 generations. Or we say if we get a value, a fitness value of 99% or higher, we stop. So that might be the criteria. So the question is, how do we take this idea of a genetic program and apply it to financial data mining? So we take the closed price, and we might have thousands of these. I've just reduced it here. We have the closed price, and we might have a moving average, RSI, MACD, all these technical indicators there. And we impose a set of rules at this point. So here's one rule. I show in green, that might be a buy condition. If the RSI is less than 30, it then goes greater than 30, we buy. Or if the RSI is greater than 70, then goes less than 70, we sell. Now you have to realize each row corresponds to 5-minute data. So it might be 10 o'clock, 10:05, 10:10, 10:15, and so forth. So time series data goes down this way. And we come up with, if we have any of these rules satisfied, we either have the word buy, hold, or sell. Okay? And this is the important information: buy, sold, and buy, hold, and sell, in terms of then applying it to see how profitable it is. So let's say we get a buy condition, whatever rule triggers the buy. Then at the next open, we buy whatever the S&P E-mini for $12.49. Time goes by, we get another sell signal, and we sell for $12.89. In this case, we would make 40 points. And to make life simple, we'll say that the fitness function is equal to all of the points that you accumulate over maybe a 2-year period, analyzing the data. You could actually figure the actual financial value, but we'll skip that for now. And so we look at, fitness might be how many points you accumulate. So here's an example of a financial rule set up as a tree structure, and I show the buy in green and the sell in red. And the second rule, the buy is in green and the sell is also in red. And so for the breeding process, we randomly go somewhere within our tree structure, and we identify a subtree here and identify a subtree there. And then we swap the pieces maybe of the buy and swap the pieces from the sell. It just so happened the subtrees are the exact size. It doesn't always happen that way. So we do this to breed equation. We go through, then see how financially viable this particular set of rules. Now the difference between this and the previous example, the generic example, I had a stopping point of maybe 50 generations, or if we get a value like 99% accuracy. This one's a little different. It's more like a simulation, and the success might be bound by like 50 generations, or you could say if we get a model that makes me $5 million over whatever number of years, I'm fine. So a little bit different how you set the exit criteria. Okay, but wait, we have a demo. Here is a program that should be familiar to some of you. And what it is, I use this in the past in financial data mining. I give students the template. This is the executable. And I give them the source code. They got to fill in a lot of the spots. And I'll show you a little example here. Do small data set. So it loads up the data set there. I'm not going to check for errors. I can so here I included 3 indicators. They had to write like 10 or more indicators to put into the software. And you see the 2 lines, the simple moving average, exponential moving average, how correlated they are. And this is the RSI. It ranges from 0 to 100. So they have this to get going. And they could do things like zoom in and so forth. But let me go over to the genetic algorithm. I'm loading an indicator set number 1 there. And bring this down a little bit. Let's go 80 and we'll go 20 generations. What this will do is, first of all, it'll set up all these mathematical buy-sell conditions, and then it'll compare and contrast, and as it goes through, it'll see how much money that it can accumulate. So we have everything set. The training process, pretty quick here. It's complete. And starting out, that's like the first generation. It had starting with $100,000, made $153,000. Had 20 winners, 19 losers, and there's the rule that's given below. Okay? Kind of hard to read, and that's fine. And then we can come down to the bottom. You see how it was 153, and it went up to $164,000. So this is, it grows monotonically, so you can't do any worse. And the idea is profit is acting as the fitness function in this particular example. So the last one, it had 48 trades, 22 winners, 26 losers. They say more winners than losers, I mean more losers than winners, but it looks like the winners made more than the losers there. You can go to show trades, and what it does is take the model and loads it up here. I give the student only this executable so they see how the program ought to work, right? If I gave them the code, they wouldn't have to do much during the semester. And a couple things you could play around with. Here we see the model made $164,000. Right here, you can do just long trades, made $134,000. Short trades, $111,000. And you could add a lot more graphs, shall I say, but it looks like the long trades did better than the short trades. You could do money management here. I won't do it, but you could set the number of stop limits there and play around with that. But here's the problem. This gets you familiar with it, but as you go through it, the advantage of the genetic program is it helps reduce the search space, and you can do thousands of these models in several hours. Okay? Tens of thousands. Okay. Let me come back to the presentation. So the genetic program, you might have 400 indicators, gets you down to a lot less. Now once you're down to a lot less, you can do optimizing of the final equation. Remember we looked at like the 1,200 permutations? And the idea here is we might have a rule, if the simple moving average for the close, 10 period, crosses the close, we would buy. If the close crosses the other way against the 12 period moving average, we do a sell. So that's an example of one model you might have. And what you can do with that model is you can apply an optimization technique, and this is something that they do in Omni Broker, for example. And so optimize, X is the term, 10 and 12 are the default values there. 1 to 1 to 1 to 1,000, that's a loop structure. and we're gonna increment by steps of 10. And the other optimize is 1 to 400, increment by 5. So 1 through 1,000 by 10, that gives you 100 times 8,000 if I got that right.